I know how to read. I just
not very good at it.
I guess you could say that.
Anything more than 3 letters is too much.
Didn't think my name's so 3 letters. Alright.
Alright, so letter H. Questions on letter H. Hang on, don't ask yet because I'm not there yet. 11H. Questions on H. Yeah.
So, like 2.
2.
Since you can't square anything, to make 1 0 is no answer for the vertical, right?
Right, there's no vertical. The horizontal asymptote would be y equals 0 because the degree on top is less than degree on bottom. No vertical asymptote because there's nothing you can plug in that's a real number that would make that 0. And then there aren't any roots because for the same reason. Or wait, take that back. Roots, -1 would be your root. And then the y-intercept would be 0, 1. Domain would go negative to positive infinity. Anything else off of H you would like me to? 10? All the way on that second or third page? Third page. Okay. Number 10. Olivia, did you need me to write anything down from that number 2 or are you okay? Number 10. We got all right, ready? Yeah. So the degree on top is 1, the degree on bottom is 2. Agreed? Even though the x comes second, that still has a first degree. Does that make sense? Yep. All right, so let's see. Number 10, vertical asymptotes. Take a look at the denominator. The denominator we're going to factor to x minus 2, x minus 2. So I have a vertical asymptote at x equals 2 is my vertical asymptote. So I know this, I'll probably regret this, but I'm going for it. Got it right so far?
It wouldn't let me.
Really?
Yeah, because they have to give them to every single class. So they were like, yeah.
What is this, like real life? I give out the sum and say there isn't enough for everybody and that's just life?
No.
I thought this was sources of strength, not reality. Here's the reality of life. Some of you will get some, but the rest of you won't.
Only some people have some. Not the rest.
I'm just kidding. I'm just kidding. All right. Thank you for trying for me, my friend.
Way to mess it up.
All right. Horizontal asymptote. Horizontal asymptote, because the degree on top is less than the degree on bottom. My horizontal asymptote is y equals 0. So again, I might be regretting doing this by hand, but it should be working. X-intercept. So 1 minus x equals 0. So negative x is equal to -1. So x equals 1. So I get 1, 0. And then y-intercept. I'm going to plug 0 in for x. I'm going to get 1 over 4. Yeesh. Anything else? Domain. Domain should be relatively easy. Negative infinity up to 2 to infinity. And then what do you think this graph looks like?
No clue.
That's why we're going to Desmos. Can we do that?
Yeah, I guess we do that.
Okay.
Are we allowed to use the graphic calculator on the test?
Oh, that's right. You weren't paying attention yesterday.
Yeah, we are.
Funny guy.
All right, Sam. Are you ready to read me what number 10 says on your paper?
Yeah, this time.
Okay. Hang on, not yet. All right, it is y equals what?
1 minus x over x squared minus 4x plus 4.
over x squared
Minus 4x.
Plus 4.
minus 4x plus 4. Yay.
All
right.
These funky shit.
It's one of the funky ones. I guess what's kind of strange about this is you have this asymptote, but then you increase and then drop. There's your asymptote. This is also our asymptote, but we have that special case where it still crosses. So that is that. Cool. So yes, to answer the question, if you don't have a graphing calculator, well, I would actually say we'll use a Chromebook, because the Chromebook Desmos is a lot easier dealing with these than on your calculator. Cool? Hey, any other questions off of H? We're good?
Turn it in tomorrow. It's not extra credit. It's just normal.
That was so loud.
You can get it in tomorrow too. Yeah.
The printer
Just-
ran out of ink, and so I was pissed. I got one sheet of it.
Were you
done
listening to
without-
loud music earlier or something? Like abnormally loud right now. I love it though. I love it. I'm just messing with you. It's like, no, Mr. Stroke, I have hearing aids. I can't hear and they're broken today. Oh, now I feel like a real jerk. All right. All right, I. Any questions on I? I'm sorry if I just offended like 2 people. I got extra credit. And
2.
number 2 on I. Okay. All right. So vertical asymptotes on
0.
I. No, it's where the denominator is equal to 0. So x equals 4 and also x equals -4. So we'll draw what we can.
Where's my
Also, mine, can we just write plus minus 1 on the graph?
Yeah. So there's my 2 vertical asymptotes. Shh. Horizontal asymptote, the degree on top is actually to the 0 because we don't have an x up there, so x to the 0 is 1. And then so the degree on top is less than the degree on bottom, so I get y equals 0. One of those. Then we got x-intercept. X-intercept. There's not any x-intercepts because there's nothing in the numerator to solve. Y-intercepts. Y-intercepts, we got 0, comma, -2 over -16, so 1/8. Is that right? Okay. Anything else? Oh, domain. So, negative infinity to -4, -4 to 4, 4 to infinity. Okay. What's it going to look like? Hit it on Desmos. All right, where's the loop? What does this center do?
It goes like from top left to bottom, yeah.
Like that? Like a U? So like that? What does this one do?
And then it's
Down?
like that, and it's like opposite, yeah.
And then this one's down? Like that? Cool. Something like that? So it's down? Like that? Okay.
During the test, will we be able to use this one?
We're going to ask Cooper that.
Of course you're allowed to use Desmos, you silly.
Yeah. And then you just have to transfer it to what's on your thing. Does that make sense?
So pretty much it's hard not for you to have.
Well, you will have to do vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts, domain, and then you're graphing it. So don't be eyeballing it like Drew will, going, hey, it looks like an asymptote's here. No, you're wrong. But we still love them. All right, anybody else have anything from that? 8? Yeah.
Each usual says
Number 8. What'd I do?
No, it's just this one.
Okay. So I got y equals x plus 5 over x squared minus 4x minus 5. So I'm just going to factor this real quick. Is that x minus 5, x plus 1? Is that right?
Yes.
Okay, so my vertical asymptote is related to that. So x equals 5 and x equals -1. So 5, 1, 2, 3, 4, 5. -1. All right, the degree on top is 1, the degree on bottom is 2. So horizontal, y equals 0.
Wait, sir.
Yeah, buddy.
When it has like 2 x's on the bottom, do you already just looking at it? Like it's x squared minus 4x. So do you not?
So I just factored x squared minus 4x minus 5 because that found me my 2 vertical asymptotes.
So how do you do the H?
Horizontal, degree on top is less than degree on bottom, so y equals 0. If they're equal, and I'll review some of that today, for sure, because there's 3 different scenarios. Two of the 3 scenarios basically is this: degree on top less than degree on bottom, y equals 0. Degree on top equals degree on bottom. Take the lead coefficients of those. That's y equals whatever that is. And then degree on top is more than degree on bottom. No horizontal asymptote. But I'll review a little bit better than that than just verbally because. All right. Let's see number 8. X-intercept. So set the numerator equal to 0. So the x-intercept is going to be -5, 0. 2, 3, 4, 5. Uh-oh. And y-intercept. Plug 0 in. So I'm going to get 5 over -5, so 0, -1. And then the domain. Domain will do something silly like -infinity to -1, -1 to 1, 2, 3, 4, 5, and then 5 to infinity. All right, what does this bad boy do? Does it do? Let's go.
Makes the backwards L on the left side and then the right.
So does it cross here? So it does this, like that.
Yeah.
Okay, and then here is like this,
It's enough. Yeah.
and then here's like that.
That's good.
Is that okay? Makes no sense? I like it. All right. So if you would, make sure your names are on H and I. Remember H, and they're just the evens. H is going to count as extra credit in the homework category. And again, if you've already done all your homework, it's not going to adjust your grade that much. The higher your grade, the less it gets adjusted. I know it's totally not fair. Yeah, I give you extra credit. And if you needed extra time to get the evens of H done, you still get extra credit.
Are you doing the final? This is actually the final extra
Oh, my bad.
I went down to I got an 80 on the final last semester, and then I had an 87. And that homework packet and that drop the test brought me to 90. So I think you should do that again. Homework packet.
Gotcha.
Like the review packet. Yes. And he dropped the test.
Drop the test. How about I just don't count any of the tests? If you turned in one assignment, you get an A.
Let's just not take the final.
Just not. God, drop the lowest grade. If you did all your homework, get you 25% extra credit points.
As a teacher, I just feel like everyone gets an A.
That's a very good deal right there.
You'd be a bad teacher.
If you showed up at least once this semester, you get an A. Things like that.
So you're saying Ben wouldn't get an A?
Ben's right there. Dude, Ben got like, what'd you get on the last test? Ben got like a 96% on the last test.
It was 43 out of 46.
Dude, I am so proud of you.
Thank you. This next one's probably gonna go a little different, bro.
I
4 out of 46.
I got full faith in you, my friend.
Yeah.
So Ben, no matter what, because you had the highest score, that means that today, that the quiz we take, you'll be the key. So it's an automatic 100%.
It's not Drew.
Now, Drew lost out. It's okay. He's getting over it. All right.
Maybe he just drew the losing bid.
So like, just run there and try to get
7.
I just
Shirley. Name's not Shirley now. Sorry.
Oh yeah.
Okay.
Amazing. I love
Notes are quick, and then I have some review that we're going to put in here, make sure we're good. So we've dealt with vertical asymptotes, we've dealt with horizontal asymptotes. So basically, the three rules to know: vertical asymptotes deal with the denominator equals 0. Okay? Does everyone feel comfortable with that? If our denominator doesn't give us any real solutions, then we don't have a vertical asymptote. Make sense? So if you have like x squared plus 4 as a denominator, I can't solve x squared plus 4 and get two real numbers. I get a complex number. I get x equals plus or minus 2i. Because I have plus or minus 2i, that means that I'm not going to have a vertical asymptote. Okay? Then we have the horizontal asymptotes. Okay, and there's 3 cases that are going to take place. Hey, what's up?
I'm just around school, right? So I was just like, I don't know, I'm taking the syrup.
Oh, okay.
And do you think I can finish my math test this period, or do you want me to do a bit?
Let's see. I don't have it with me.
Okay.
Let's take care of it later.
All right.
Thanks, brother. All right.
Just wandering around school.
I was like, I need to go to this
Things that happen in Sterling class. Love it. All right. So horizontal asymptote, there are 3 scenarios that could take place. We could have something like y equals x to the 5th over x to the 7th, and I have plus blah 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 plus blah blah blah, and maybe we put a 2 here and a 3 here. So I have 5 is less than 7. Agreed? So top is less than bottom. Is that okay to say that? If top is less than bottom, then y equals 0 is my horizontal asymptote. Good so far? All right, so next scenario. Does someone need me to write out, seriously, entire Sam, hush. All right, then there's times where I might have like 3x to the 7th plus a whole bunch of more stuff. And then I have 5x to the 7th plus blah, blah, blah. So I get 7 is equal to 7, so top is equal to bottom. And that's going to give me y equals whatever the coefficient on my highest exponent is. So that's to the 7th to the 7th, so 3 over 5. So y equals 3/5. Is that okay? Does this make sense? And the third scenario that we haven't really seen or talked about a whole lot, but let's say we had y equals 3x to the 7th plus over 7x to the 2nd plus. So 7 is greater than 2, so top is greater than bottom. That means we have no horizontal. But this means we have end behavior or oblique. I think is the term they use, QUE. There's an E there. Okay, that just means where is the graph going at the ends, and you actually have to use long division to get there. And there's some teachers that teach this totally wrong, and then you have the stirrup teacher. End behavior asymptotes don't have to just be linear. They could be anything. Now some teachers are like, no, this wouldn't work. If it was too far below, it's not going to work. It's like, I'm not quite sure where some people studied math. They might have all went to Ohio State or something.
Oh. What do you have against Ohio State? You roasted it yesterday.
I speak a little quicker than those people who go there. So.
Okay, what did Ohio, I'm curious why Ohio State.
I'll denounce you.
Like, what happened?
Dude, because I love Michigan.
Why do you like Michigan so much?
Oh, man, I've always loved Michigan. I don't know why.
Can't believe that answer.
Well, Arizona State was number one, but like then if Michigan was playing Arizona State, I had to root for Michigan because I just love Michigan. I don't know why. It was just it. But then Arizona State was never really good. You know, they have like one big season that they do good, and they're like, oh, we're the best. And it's like,
U of A is better.
U of A. I hate to say no.
We're cool.
Okay. All right. So that's basically that's getting us to where we are now. Okay. Now then they say, hey, simplify the expression. They're like, okay, yay. On bottom would simplify to this. And if we were to simplify it, I could do tug of war. And so this winds up with 3x over x minus 2x plus 2. Okay, and yes, you could put it back together. So that's the most part on that. These aren't graphing, we're just having to realize things. And then this is x plus 5, x minus 5. I don't know why that's real difficult in Algebra 1 for people to recognize difference of two squares, but they have a hard time sometimes. Then I get x minus 6 and x plus 5. What cancels?
X plus 5.
X plus 5. So a whole binomial can cancel on this. And this is actually what we're going to focus on today is when that happens. Because when that happens, you actually create a hole in your graph. And a hole is not like an asymptote. A hole is where the graph is drawn, and then it stops, and it keeps going. And you know the slope of it and everything still remains the same. It's just you have a gap in your whole thing. This one, if I were to factor it, looks like top would be, what was that, x minus 8 and x minus 4. Did I do that okay? And then the bottom is going to factor to x plus 8, x minus 4. So the x minus 4s would cancel. And again, that's going to be what we're dealing with today. And then the last one, let's see, I can factor out and x, and then I get, what is that, x squared, x plus 3, x plus 4. And I know I'm factoring them quickly, so those of you who have trouble factoring, I apologize. That's going to be x minus 5 and x plus 2. And then the x's would go ahead and reduce on that. But again, this is all creating scenarios where we will have holes in our actual problem itself.
Is that not like the ones where it's like a flat line and then
And
it dips down?
nope. You probably have drawn these having holes and you've never seen the hole on your calculator. And Desmos won't show a hole, but the graphing calculator sometimes will. But you got to zoom into like 3 angstroms. You don't know what an angstrom is? That's the distance from the nucleus of a hydrogen atom to the s orbital at 1 STP at 0 degrees Celsius.
Sounds like a lot of
10 to the negative 8 meters. So it's 10 to the negative 4 millimeters. So if you take a millimeter and you broke it into, it's real small. All right, so these are some of the rules we just worked with. Okay, locate the hole for the function. Okay, so we factor it first. So the top is going to factor. So this is going to give me 2x plus 4, x minus 4. The reason I know that is if I factor out the 2 originally, and I get x squared plus, or minus 16. X squared minus 16 breaks up to x plus 4, x minus 4. Then I factor the denominator. So I get x plus 9 and x minus 4. Is that right?
So minus 4.
So because these are going to cancel out at 4 comma something, we will get we will find a hole, and we're going to get to that. Okay? So we're going to be able to see the holes eventually when we start graphing these. But a hole basically would look like this. Your graph does this, stops, does this. It's like it's missing a portion. It doesn't act as an asymptote where it shoots up the side of it or down the side of it. It keeps going in a direction and it's like, hey, we got a hole. Like if you were wandering along, if you were playing one of those games on your phone that has a hole and your ball was supposedly rolling, it would fall through that hole. And and you would maybe want to make your ball bounce at a certain thing so it goes over the hole. Number 6, this factors to x minus 5, x minus 2. The bottom factors x minus 5 and x plus 4. Do I have the same binomial on top and bottom? Yeah, here and here. That's going to create a hole at 5 comma something.
How do you find the something?
We're going to get there. We're not there yet. I'd like to say you plug 5 in, but what would happen if you plug 5 in right now? You'd get a 0 on top, you get a 0 on bottom, you get 0 over 0, and that 0 over 0 is undefined. Wait, 0 over 0 is undefined, it's not 0? No. Sorry, some news.
Some kid just got a 0 on his test.
Alright, so let's simplify this bad boy.
Probably.
So I have f of x is equal to 2x plus 4, x minus 4, over x plus 9, x minus 4. Where is my hole? It's at 4 comma something. Why is that? Because that, if I set those equal to 0, well, we're going to figure out the something here in a moment. Vertical asymptote. Degree on top is equal to degree on bottom. So I go to my horizontal asymptote. So my horizontal is y equals 2 over 1, which is 2. My vertical asymptote now. Did one of my binomials get eaten up by a hole on this problem?
Yeah.
So what's my only thing left in my denominator on this problem?
X plus 9.
X plus 9. So my vertical asymptote will be at x equals negative 9 because of that, because that's all that was left. The whole supersedes an asymptote. And then x-intercepts, let's see, so x-intercepts, I would take my numerator, or I'd take right here and say, hey, what's going on with that? I'm going to get negative 4 comma 0. My y-intercept, if I plug 0 in for x, I'm going to wind up with plug 0 in for x, I'm going to wind up with, I can't plug it in here. Let's see, that's going to be 8 over 9. If I plugged it in here, I'd get negative 32 over negative 36, which reduces to 8 over 9. All right, so let's plot what we see up here, and then let's figure out if we can decipher anything else about this problem. All right, so
Like nearly 1.
I have a vertical asymptote at x equals negative 9. Is that okay so far? I have a horizontal asymptote at y equals 2. Is that okay so far? I have a x-intercept at negative 4, 0. I have a y-intercept at 8/9. So about right there. Okay? And then we have a hole. Let's figure out how in the world this hole is going to exist for us. I want to find out what the y component of the hole is. I can't take that 4 and plug it back into the original because I get undefined. So what I'm going to do is I'm going to take that 4 and I'm going to plug it in here and here. So my reduced version of this graph is 2x plus 8 over x plus 9. Okay, if I've gotten rid of the hole. So if I take 4 and plug it in there, 2 times 4 is 8. 8 plus 8 is 16 over 4 plus 9. So at 16/13. And where in the heck does 16/13 exist? Well, it's 1 and 3/13. So at 4 and 1 and 3/13, somewhere in here, we're going to create a hole. Okay? So I'd say this graph probably looks something like this. I'd say it looks something like that. Can you guys see the hole? If not, it's right there. Cool? All right. So now, Desmos doesn't allow us to see the whole real good. We'll use Desmos first, and then I want to show you on the graphing calculator how to make that work. All right, so Desmos, yay, it's loaded like that. All right, so I get 2x squared minus 32. Whoops. Minus 32. All right, okay, divided by parentheses x squared plus 5x minus 36. Okay. Does that right there look kind of close to what my graph is?
Yeah.
Okay. So where did we say the hole was on ours? At 4 comma something, right? Okay, so this is how we can decipher a hole here. Right there. 4 comma what?
Undefined.
Is undefined a number?
No.
Today it is. All right, so I could zoom in on this and I'm not going to see the hole on this. Okay, so now I wanted to show you on the graphing calculator, because you might not have Desmos handy with you. So if you have your graphing calculator with you, let's show you what this looks like. Okay, so you saw that 4 comma undefined means something. Yes? Good. All right, come on, TI. Fire up a little faster these days. All right.
Mr. Startup, thank you for finding my calculator.
What did I do?
It's not my calculator.
I found it?
Yeah.
I didn't know it was lost.
Well, it was for a while.
Oh.
TI more like gotta call IT.
What?
Squared plus 5x. Okay. Zoom 0. Let's change that window a little bit. Let's go to negative. Does that kind of look like the graphs we've been working with? Yep. So if I went second calculate and I knew I wanted to find a value at, where was the hole at? What time?
16 over 13.
Okay, good for trying. 4 comma something. What do you notice about the y? So there's no y down here, agreed? I plugged in, I want to find the value at x. There's nothing here. Okay, this nothing doesn't mean 0. This nothing means the calculator's going, there's nothing there. Oh, so it's 0. No, 0 would be right here.
Oh.
It's not there. That means that there's a gap in this. So, on the graphing calculator, if you wanted to see what the hole actually looks like, we're going to change my window, and I'm going to go from negative, oh, I take that back, I'm going to go from 3.99999, sounds good, to 4.00001. Okay, so do you agree in the x direction that's right around 4? 3.999 is really close to 4, and 4.0001 is really close to 4. Agree? So if I graph it, all right, I gotta find where it is.
What about that thing in the middle of the line?
What's that?
Like a dot on the line.
Yeah, that's 4. So I'm gonna get close to that, as close as I can to it. We're at 4. All right, ready? Zoom in. Thank you. Enter. Oh, 1. Oh, crap. Quit. Zoom out.
Just go to
You're killing me. Y equals 1 equals y equals. All right, window. Oh my gosh. Graph that. Your window range is goofy. You're killing me. All right. So if I go to the second table, where was it at? At what? 4 comma what?
16/13. Here. I don't know.
Is that a number?
No.
Not this week. Okay, so Desmos will tell you 4 comma undefined. Your calculator under your table will give you 4 comma error. Sometimes on the calculator, if you draw it appropriately, you can see it. Sometimes on the graphing calculator, it kind of looks like a heartbeat EKG. It goes like this, where the hole is. But sometimes you can't find it exactly. But at 4 comma error, there's something definitely taking place on our graph that is not an asymptote. Okay?
Some gypsy.
What did I do?
Some gypsy.
Some gypsy stole it. Okay? Orange.
Darn. Got gypped.
It happens. All right. So, go here. So, does that make sense with a hole?
Yeah.
Okay. Do you feel comfortable about how we just found some holes?
Yeah, that makes sense.
All right. Let's move on.
Once I know it now.
54. All right. Let's factor the top. So, is that x plus 6, x plus 2?
Yes, sir.
And is bottom x plus 2x plus 9?
Yep.
Yeah. So the x plus 2's, that means I have a hole at x equals -2. So at -2 comma something, we're going to have a hole. So let's just do this. Go highlighter here at x equals -2. Somewhere in that yellow range, the graph is going to approach it, skip over it, and keep going. Okay? So we'll do the hole in yeller.
So we just plug it in then?
All right, vertical asymptote. Vertical asymptote. What is left in the denominator? So I have a vertical asymptote at x equals -9. Is this purple dotted line the same thing as a hole? No, it's an asymptote. Our graph's going to go right up alongside of it. Horizontal asymptote, degree on top is equal to degree on bottom, so lead coefficients are both 1. So I get y equals 1. X-intercepts, is there anything left on top? Yeah, I have, looks like at x equals -6, so -6 comma 0. Y-intercepts, well, if I plug 0 in for x, I'm going to get 12 over 18, which reduces to 2 over 3. All right, let's see if we can draw this. See how my graph doesn't... Yes?
Yes.
Feel good? Does that make sense? What's the difference between a hole and an asymptote? An asymptote, we approach, get really close to. A hole, our graph jumps over it. We miss it. We avoid it. Okay? And yes, there are extras here that we could go over, but it's all going to be the same thing. So I think homework tonight should be J. J evens, okay?
Yeah.
And then we are still set for a Friday quiz. And to answer questions, Desmos is allowed. I'll provide the Chromebook. Or if you want to use your graphing calculator, you can use your graphing calculator. I think Desmos is easier for you to use. Also, a reminder, guys and girls, let's have you start getting that, the Schoology, that is an assignment. It's open, but I think you are all totally ready to do the capstone, so come see me. Get the capstone done. It's quick. It's easy. Let's get done. We'll be happy. Hey, Drew, get up here. Hey, wait, guys, we got stuff going on here.
Drew. Oh my.
All right, I'm coming to you. What happened?
What happened, man?
Oh my god.